Today we're going to talk about how we solve our quadratics using our square roots and what we know about our square roots. The very first thing that we are going to notice is that here in the standard form we have ax squared plus c equals 0. We don't have the bx in there. And what that's going to do for us is that means all of our x's are in one term and they're in one location. So because of that, I'm going to be able to easily move the other numbers away from it and be able to solve for x without having to graph, which of course some of us are going to be very happy about. So here we have in our first example, we have 3x squared minus 27 equals 0. So using SADMAP, we are going to undo the minus 27 by using the inverse and adding 27 to both sides. Remember how we always make sure we do the same thing to both sides of our equation. By doing this, we're going to get 3x squared equals 27. At this point, we know that in PEMDAS, the exponents would come before our multiplication, but in SADMAP, we have to undo the multiplication or the times 3 before we would take the square root or the exponent. So then we would divide both sides by the 3. And that's going to give us x squared equals 9. Now I can take the square root of both sides. Remember, squaring and square rooting are the opposites or the inverse. Once I take the square root of both sides, that is going to give me the answer x equals 3. But don't forget, we also have another number that will be times itself to give us a 9. It's also a negative 3. So we have to remember when we take the square root, we want to make sure that we have both answers in this case. So x is going to be plus or minus 3. Okay, on the next one, we are now looking at trying to isolate x squared. So to isolate the x squared, I'm going to use my SADMAP and add 10 to both sides of my equation. That is going to leave me with x squared equals 0. I don't have anything else to move away from x squared, so I can take the square root of both sides. And by taking the square root of 0, I get 0. So that would tell us in this equation that we only have one solution, and that solution would be x equals 0. For example 3, we have a little bit more work to do on this one, so my very first move, again, is to undo the plus 11. I do 16 minus 11 on the right to get a 5. I have a negative 5x squared. The next thing I need to do is I need to again isolate at least the x squareds, so I'm going to divide by the negative 5 first, and that is going to give me x squared equals negative 1. And the problem I have here is that when I go to take the square root, we have a negative 1. When I go to take the square root of a negative number, we know that that is not possible. So when I take the square root of a negative, we end up with undefined, because I can't take the square root. And when I say something is undefined, that means that there is no solution. Okay, there are no real numbers that will be the negative 1, the square root. So as a quick summary here, when I look at x squared equals d, so that d is when we get down to that last term right before we take the square roots. When you think about it, if I have a d value that is greater than 0, that would tell me that I have a positive number. And as long as it is greater than 0, no matter what happens, I'm going to end up with 2 real solutions. And that would be an example like in number 1, where we had x squared equals 9. Well, both 3 and negative 3 give me 9 when I square them. So that means that there would be 2 real solutions. For example, when we got to d equals 0, so the x squared was now a 0. What that was basically telling us was that we were now going to only have one solution, and that would be when x's are the 0. And then we got to the third example, which was example C. And in that example, when we got down to the x equals, and we isolated x squared, when I have x squared equals a negative number or less than 0, then that would tell us that we have no real solutions or 0 real solutions. So that's kind of the summary of what we are looking at. In this next example, what we're trying to do is we're using square roots to be able to solve the equation. So what you're going to notice in here is right away we do have a little bit more work to be able to take out the -1, which is attached to the x. So the first thing that I'm going to do in this one is I'm actually going to take the square root of both sides. And by taking the square root first in this case, and the reason we would do that is because parentheses is the first thing we would do in PEMDAS, so in this case we're actually going to do it last. But by taking the square root of x minus 1 squared, I actually end up with x minus 1. And then I remember on the other side, when I take the square root of 25, just remember that there are actually two square roots of 25, both 5 and -5. So here's where we have to remember that we have to kind of split off a little bit and solve for our two different answers or roots. I'm going to do x minus 1 equals 5, and I'm also going to do x minus 1 equals -5. And then once I go through and solve the rest of this, I would add 1 to both sides to tell me that x equals 6. I would add 1 to both sides over here to get x equals -4. So that would tell me that my solutions to this equation are both -4 and 6. But we have to remember that we take the square root of 25, we do actually have a both positive and -5. So this last one has got a little bit of work to do here. We kind of have to use a little bit of what we know about some different things. So when we first read through this, the touch tank that we are looking at has a height of 3 feet. We know that the length is 3 times its width. So basically I'm going to call this side over here my width. So x equals our width. I know the length then is 3 times that. So that would be the length of this rectangular prism. And I know the volume of the tank is 270 cubic feet. So basically what I'm going to do is think about the volume, because we're talking about volume, of a rectangular prism, which is volume equals length times width times height. Basically that is saying our length, we said, was 3x, our width was x, and our height, which was given to us, was 3 feet. So basically the volume is equal to 9x squared. So again, the volume was given to us as the actual 270. So if I do 9x squared and I replace v with the 270, which was the number they gave us, I now have to solve for x. And again, because x squareds are all together as one term and there is no other bx, I don't need to try to factor this, I don't need to try to graph this. I can now just try to solve and get to what x equals. My first move is to divide by the 9. So I divide 9 on both sides. That's going to leave me with x squared equals 270 divided by 9, which is 30. Once I get to this point, I know I'm going to have two solutions, at least for the equation goes. And when I take my square root of both sides, I'm going to actually get answer of x equals the plus or minus square root of 30. Okay? Now, really, the square root of 30 is my answer. I don't really want to have the negative square root of 30 because that certainly wouldn't make any sense for us to have a width, which was our x value, of a negative. So we're definitely just going to kind of throw away the negative part, and we only concern ourselves with the positive. And then reality goes, you would never tell somebody, oh, well, the width of that is the square root of 30. So we probably really want to use our calculator here to kind of figure out, well, what is the square root of 30? So my answer is initially square root of 30 feet, but really that doesn't make a whole lot of sense. I'm probably going to want to use some way of making it a little bit closer to realistic, to saying it's about 5.5 feet. And then that would tell me that the length of this pool, again, is 3 times the square root of 30, which is approximately 16 feet. So there are times that we're going to see things in standard form, and we're going to see it in standard form without the bx. And then you might want to decide this might be a faster method of being able to solve instead of thinking about trying to graph it, trying to figure out where the x-intercepts are. If you only have all the x's in one term, it's a little bit easier just to kind of run through your algebraic equation solving and be able to find out what your x is a little bit quicker.